Hi, today we're going to continue to find the volume of solid of revolution. So let's take a look at question number 1. So we have the semicircle y equal to square root of 9 minus x squared, and this is the shaded region. Underneath the circle is bounded by the semicircle in the x-axis. Rotate the shaded region about the horizontal line y equal to negative 2. Then find the volume of the solid. Now we had to draw the line y equal negative 2. It's not given to us, so we're going to draw it. So this is negative 1, negative 2. Okay, so y equal negative 2. Now we're going to pick a point on this line. We call it the axis of revolution. So don't pick a point at the end, pick a point in the middle. Okay, so this way you can see the radius better. So as we said before, if you rotate, you always get circular motion. So your cross section always has something to do with the circle. So now we know that it has something to do with the circle, so we are going to find radius. Now from here, we are going to hit the first equation you hit is going to be the x-axis, y equal to 0. So now we stop. So we say that from the axis revolution to this graph or this line, y equals 0, you're going to bound the small radius. So we say that the small radius is equal to the distance between y equal to 0 and y equal negative 2. So we are going to say that r equal, to find distance, we're going to subtract top minus bottom. So 0 minus negative 2. So r equal to 2. So you can see it. The radius is a constant. It's always 2 units. Okay, so now we finished. We got our first radius. So now, so I'm going to do 2 units, and then 2 units, I will get my inner circle for my cross section. Now I am going to go back to the same point. I am going to draw the big radius because we do have another function over there. So we go up, and then you found out that you're going to have your big radius. The radius between y equals square root of 9 minus x squared and the axis of revolution is always between the curve that you hit and the axis of revolution. So the big R is going to be the distance between y equals square root of 9 minus x squared and y equal negative 2. It's always between the curve you hit and the axis of revolution. So now to find the distance, we subtract. So it's top minus bottom. Square root of 9 minus x squared minus negative 2. So we simplify. R equal square root of 9 minus x squared plus 2. So we found our big radius. So now I am going to draw my cross section. Okay, so now it's kind of difficult to see, okay, how it look like. Okay, so if you imagine it rotate this way, so let me just do a little bit art piece over here so maybe you can see it better. Okay, now do you see it? It basically looked like a ball, and then it has a middle part is halo. Okay, so it look like this. Now even though you cannot imagine how it looks like, but you still can see the cross section is you have a small circle and a big circle. So now let's go back to the formula that we derived yesterday. So we say that v equal to integral a to b. We're going to go with the very general one first. Area of cross section and then dx. The reason is if you chop them, so every single slice we're going to have a cross section that look like concentric circle, small circle and big circles. Okay, and the dx is the thickness of each piece, or the little height. So now because the area of the cross section has something to do with the small circle and the big circle, so therefore we say that it's going to be integral a to b pi big R squared minus pi small r squared, and then dx. Now we have the pi in common, so we're going to factor out the pi. So now we're going to have integral, so a to b. So now I'm going to find out what my smallest a is, from -3 to 3. So therefore -3 to 3. The a is going to make it 3 and b is going to be 3. And after I factor out the pi, I get big R squared minus small r squared dx. Now you're going to do substitution. R is a function square root of 9 minus x squared plus 2. Okay, so now we're going to be parentheses square root of 9 minus x squared plus 2 whole thing square minus the small r is 2, so minus 2 squared dx. Okay, I'm going to ask you to use a calculator to calculate this. So we're going to go back to our calculator. I'm going to use my y1 because I don't want to type in this whole thing. Sometimes getting complicated when you have your r is a very complicated one. So I'm going to make my y1 equals square root of 9 minus x squared and then plus 2. So this y1 is my big R. Now I go back, map 9. Okay, I'm going to add -3 to 3. Big R squared, so y1 squared. Okay, my small r is 2, right? So I just minus 2 squared. Okay, I don't need to use y2 squared. If you want, you can do that. And then dx. And then press enter. Okay, so let's see, I can change this back into a fraction. Okay, so it is a fraction. So now I'm going to copy this fraction over. So we're going to get pi times okay, so now we like to put the pi on the right side, so therefore we're going to put 73307A pi over 7921. So we finished. This is the volume of this shape that we got from revolution. Now let's go to question number 2. Question number 2 is basically the same graph, y equal to square root of 9 minus x squared. It's bounded with the x-axis, y equal to 0. So this is the shaded region. Okay. So now part A. Rotate the shaded region about the horizontal line y equal to 0. Okay, it rotates about the x-axis. The axis is a part of it. Okay, then find the volume of the solid using integral, no calculator. Okay, and B, what do you notice? So this one is a very special one. So this is a semicircle. If you spin the semicircle this way, really, really fast, what do you think you will get as a 3D figure? Okay, one more time. If this is a semicircle, you're gonna spin this way. What do you think you're gonna get? Okay, some people probably already noticed that it's going to be a sphere. So we're gonna prove it's going to be a sphere. y equal to 0 is the x-axis. So this is the axis of revolution. This is the center of revolution. And it's part of the shaded region. So now you go over here, you're going to pick a point, any point on this except the end point. So you can see the radius. So we say that when you spin, it always becomes circular motion. So now you're going to have to hit, you're already on one of the part, and you go up, you only can hit the other curve. So now you will find out that there's only one radius. You're already on y equal to 0. You're going to hit there's only one radius. So that means okay, of course my drawing skill is not perfect. So you will have a sphere that is totally solid. There's nothing empty, no halo part inside, because there's no distance between the y equals 0 and the x-axis, the one that you rotate about. So that's why there's no inner or outer radius. There's only one radius. Okay. So now only one radius. So the cross section is pi r squared only. Okay, so now let's find out what r equal to. So r equal to the distance between the curve it hit, which is y equal to square root of 9 minus x squared, and the axis revolution y equals 0, which is part of it. So now r equal to square root of 9 minus x squared minus 0, and you simplify, then you will get square root of 9 minus x squared. So now we go back over here. Volume equal to integral a to b, area of cross section, okay, dx. And this time your cross section is only one circle, so therefore you get integral a to b pi r squared dx only one circle. You don't have to subtract the big circle with the small circle. There's only one circle because there's no space between the axis revolution and in the shaded region over here. There's no space in between. Now we are going to do, I'm going to put a pi in the front, make it easy to calculate, and I'm not allowed to use calculator. So now a to b, negative 3 to 3, and my r is square root of 9 minus x squared whole thing squared dx. Now the square root and the square cancel, so I get 9 minus x squared dx, and I put a pi in front. So next I'm going to integrate. Okay, so I'm going to do pi 9. Okay, let me copy it over to make it easier for you to see the integration. So pi stays the same. The entire derivative for 9 is 9x, and then you minus, and then you have x3 over 3 bracket negative 3 to 3. Now we're going to do substitution. 9 times 3 minus 3q over 3 minus, okay, so you get 9 times negative 3 minus negative 3 to the third power over 3. Okay, now we just simplify. 27 divided by 3 is 9. And then you get negative 27 minus, this is going to be negative 27. Negative 27 divided by 3 is going to be negative 9. Okay, now we're going to have 27 minus 9. Then you do property. Okay, so this is going to be positive 27. And then this positive, and then you times the negatives become negative, so negative 9. Alright, so now we are going to simplify this. So 27 plus 27 is going to be 54, 9 plus 9, 18, so minus 18. So we're going to get 36 pi. So the volume is 36 pi. So we found the answer with our calculator. Now, we said it before, this is a sphere and the volume is 36 pi. Then it should match if I use the volume formula for a sphere. So now, for a sphere, B equal to 4/3 pi r cubed. So now, my radius is 3. And then I simplify, I got the same answer. So our prediction was correct. When you spin the semicircle over the x-axis, or about the x-axis, you will get a sphere. And you use the integral or the formula, you get the same answer.